All right, welcome back to lesson 3, part 2. I wanted to take a break because I wanted to grab a part of the data booklet with the redox table to go over where some of these reactions came from. So we have all this present in our solution. So we have a few oxidizing agents, mostly oxidizing agents, and we need to find out which is going to be our strongest oxidizing agent. We already know it's H plus and MnO4. Not likely will it be H2O. H2O is very middle of the road, so it usually doesn't want to get involved. Usually it will be our H plus and MnO4 or our K plus. We're gonna hop into our data book here, and we're looking at oxidizing agents. Oxidizing agents again undergo reduction, and I'll just make sure to put the note here. We have our strongest oxidizing agent at the top, and going down they become weaker. We have our strongest reducing agent at the bottom, and they get weaker as we go up. All right, we need to find, well, already looking down here, K plus is down here. Is K plus a good oxidizing agent? No. K solid, potassium solid, is an excellent reducing agent, but K plus is a terrible oxidizing agent, so that means it doesn't want to get involved. Let's scroll back up. We did say that H2O is an option, and there are so many options with H2O, but usually though they never work out as well as we'd hope. Let's see if I can find H2O. Here is H2O. It's a little higher up. Now the other one we had was H plus and MnO4 minus. Now a lot of what you'll see here on a lot of these is that they already have H plus. So that must be present for it to react. I just pointed that out for you. Let's find our MnO4 minus. And what we'll see here is it's right at the top here. It is an excellent oxidizing agent. It has to react with hydrogen. And again, our products are Mn2 plus and 4H2O. Go back to our half reaction down towards the bottom here. MnO4 minus plus 8H plus the 5 electrons will produce Mn2 plus H2O. And then below we have Cu, which is copper solid, and it is going to produce Cu2 plus 2 electrons. This is number 2, reaction 2 here, as I pointed out, is undergoing reduction or oxidation. It's undergoing oxidation. Cu is a reducing agent. It is our strongest reducing agent, and it wants to undergo, oxidation, is what that means. All right, and then again, like we did in the first lesson, we find our net reaction. All right, we have a couple other examples here we're going to go through. I'm not likely going to flip as much back to the I'm not going to flip back as much to the what's the term I'm looking for, to the data table. However, though, feel free to pull that out on your own and then see where these reactions are coming from. And then there already is on Google Classroom posted questions 1 through 5 from practice sheet 4. I'd like you to do that afterwards, please. However, though, you can do the 3 that follow, which one of is already done, so you'd have 2 questions due for practice. I'm going to do one example. I don't want to do too much time. There will be another video posted on Friday, tomorrow, that you can watch that'll explain a little more of this and how this is done. All right. I am going to choose to do the second example on this page. So for example, in a chemical industry, could copper pipe be used to transport a hydrochloric acid solution? To answer this question, A, predict the redox reaction and its spontaneity, and B, describe 2 diagnostic tests that could be done to test your prediction. All right, we're going to largely focus on A here. So it tells us we have copper pipe. Copper pipe would be Cu solid. And we have a hydrochloric acid solution. So we're going to have H plus. We're going to have Cl minus. Make sure I put my states. This is aqueous. Cl minus, also aqueous. And this is a solution, which means we have H2O in liquid. And we know that liquid water can be an oxidizing agent or a reducing agent. Cl minus is a reducing agent. H plus is an oxidizing agent. And Cu solid is a reducing agent. When we go to our table, what we find is that copper, a lot of times we're going to have metals. Metals are, as a solid in their atom form, are going to be our best reducing agent, and copper solid will be our SRA. If you'd like to go over to the table and check that out, please pause the video, click now, and go do that. And then what we also find is that H plus is our strongest oxidizing agent. So our reduction reaction is our H plus because our strongest oxidizing agent undergoes reduction. So we go 2 H plus, which is aqueous, plus 2 electrons. Again, this is from the data table. You can hop over to that and take a look. Uh-oh, gotta scroll back down. All right, plus 2 electrons produces, oops, not 2. This will be H2 gas. And then, I will shift to green, we have our oxidation reaction, which is our strongest reducing agent, which is copper. And copper solid undergoes oxidation to produce Cu2 plus, which, don't forget, is an aqueous form. This is in your data book, was where this is coming from. The data table for redox reactions, plus 2 electrons. What happens to our electrons? They get crossed off. Let's write out our net reaction. And our net, NET, will be 2H plus, which is aqueous, plus copper solid, and it produces H2 gas plus Cu2 plus, which is aqueous. It wanted us to find out the spontaneity of this. So let's go take a look for our H2 and our Cu2 plus. Let's find copper. Where is copper Cu2 plus? It is, I'll put my highlighter so we can see it clearly. Cu2 plus would be here. And then we need to find that reaction of H, which when you're doing these on your own, you would have this done already. And when we find our reaction of H2 gas, so there's 2 electrons, highlighter, and the H plus is here. Now, we have our, if we go back to our spontaneity rule, which is here, our oxidizing agent has to be above a reducing agent. But we know that our oxidizing agent is H plus, which is below copper solid. H plus is below copper solid, meaning that this is not spontaneous. So we can represent that in a few different ways. We can put it over our arrow in our net reaction and say this is NS, or just make a note saying not spontaneous. All right. There will be a brief video to review this concept tomorrow, and that will be the end of our week. We will start topic 4, talking about oxidation numbers next week. Thank you for working with me this week. Make sure that for actual work this week, you have practice sheets 1, 2, 3, and 4 done. Those are going to take some time. And then my number one concern that you need to have done, please, is that assignment that was released on Monday, the reading assignment that you need the textbook for. Have a great weekend. Enjoy. We're going to get going again on Monday. Talk to you later.